Right. So this looks at period three. Well, it's different from a group. Groups go down, periods go across. So this table control. Let me get my funky pen. Here we go. There we go. Blue. Okay. So it says the table below shows the melting points and atomic radii of period 3 sodium to chlorine. So here we've got the melting points, and you see, well, hey, we go from sodium, bit cooler than boiling water. Boom, we have a jump up to 600 degrees, massive jump. Hey, it kind of stays steady. Then boom, up to silicon, and then it drops down again to phosphorus and sulfur and chlorine. Well, that's melts at quite a cold temperature. Then we look at atomic radii. Ooh, smaller, smaller. Diddles all the way to chlorine. So 1 picometer, the pico is 1 times 10 to the minus 12 meters. I am not going to explain to you what that means. Explain the difference in melting points for the elements sodium and magnesium. Okay, let's have a look. We've got 3 marks. Magnesium ions have a higher charge. Really? Well, yeah. The way to think of it is sodium as an ion would be Na plus. Magnesium Mg2 plus. And the way to look at it is, because of this, they're more attracted to each other, because the positive charges are more attracted to the nuclei, they're harder to separate when you heat. Therefore, magnesium would have a higher melting point. But the other way to look at this, the more accurate way, is these are ions. These are metals, but if we think about what the ions are, you look at this. Sodium wants to get rid of 1 electron, magnesium wants to get rid of 2 electrons. So what you actually have is, there's a magnesium more delocalized electrons. So even though they're not charged per se, they haven't donated their electrons away, magnesium will lose 2 electrons in this delocalized cloud, while sodium will lose 1. Okay, so what you're going to have is much more of a negative cloud, which is attracted into the positive nuclei. So magnesium will have greater attraction between the ions and electrons. And that kind of, I really like saying that. I don't know why in my head it's not really, when I talk about ions, I don't really see magnesium as an ion, or technically it is Mg2 plus and sodium is Mg2 plus, because the electrons are part of the delocalized cloud. To me, it's something like a metallic, and it is a metallic bond. It's a different picture in my head. So even though you'll get a mark for saying Mg has greater attraction between the ions and electrons, I personally would say magnesium has greater attraction, and get rid of this, magnesium has stronger metallic bonds. But both are right. Okay, sulfur, where we have sulfur here, exists as an S8 molecule and chlorine is Cl2 molecules. Use information to explain the difference in the melting points. Well, the molecules don't bond with each other. So what you have is what we call intermolecular van der Waals forces. So we'll start off by saying Cl2 and S8 have you can call them intermolecular. I'm used to calling them van der Waals. Van der Waals forces, right? So, SA, the bigger the molecule gets, is bigger. Because there's 8 of them. There's 8 sulfur atoms is bigger. Therefore, and we use the mathematical term, therefore, stronger van der Waals forces. Van der Waals forces, VDW, van der Waals forces, than Cl2. And how many marks? Oh, I've got my 2 marks. No, that's fine. That'll do me. So if that makes sense, they're both little molecules compared to these, massive structures of silicon and the metals. But S8 is bigger than chlorine, therefore it's stronger van der Waals forces. Okay, let's go down a bit. So, let's do it in part 2. Part